And we're live. Oh man.
So live.
Let's stop this. Let's stop that. Let's stop the cool music. Now we're getting serious.
Let's have background music the entire time.
We could have some. This is called Feeding the Ducks.
Oh, because of StreamYard. Right. StreamYard is a duck. They have a duck theme. I don't know.
We can leave the tunes on, man. I'll dance the whole time. I don't mind.
Can we use that? Can we have background music? Or just like we need some maybe some sound effects. Like whenever I say something shocking, you're like boing, something like that.
It's a little bit of a bitter point that you bring that up, because I actually really would love sound effects. I'd love visual effects. I need to get OBS configured.
Yeah, OBS with the Stream Deck. I mean, at that point, you pretty much sold out. You're done.
I've got a Stream Deck right here, buddy. Yeah, man. That's how it's great. I love it.
So, all right, I'm going to give you one more tip, and then we can jump into the topic. But I think, and this is just because I love you, and I want you to have the best. I think you should just set up an entire like StarCraft sound theme, so that everything, like when you start a new cluster, it's like that sound, like when the new factory goes online.
Yeah. In an ideal world, like I want to have like the visual cues. Like for example, when I'm benchmarking a cluster, I want to get the metrics on the screen, right? Like I want to get all that stuff up there. I want to get the easy cast stress output, like data, like the little the bar at the bottom, the banner at the bottom. Like, oh god, I don't even know. Create a banner. Bruce Banner,
yeah, or the Hulk.
Look at that. Boom. Now we gotta. It should be scrolling along the bottom, I guess. Is it? There it is. Yeah, look at Bruce Banner.
All right. Wow.
All right. Well, maybe we should talk. Maybe we should talk about what we're here for. It's been a while. We haven't done a thing like this in forever.
No, we've done it in person and privately, and then which is probably better, because a lot of those thoughts just don't need to see the light of day.
Yeah.
So
we you and I have a rich history. We have a very, very rich. Maybe we should give a little history. Maybe we should talk about who you are, just in case someone doesn't know. Maybe we should talk about. Why don't you give me a little bit of details? Who are you?
Yeah, who is this guy? Yeah, I feel like So let's see. If how far back? Well, I was born. No.
Yeah. Tell me about the volcano that erupted.
Yeah. Yeah. When I was hanging out with dinosaurs and the comet came, I'm like, oh, I need to switch careers. So I got into distributed computing.
Yeah, I want to know. That's how we got to get. That's what we need to get back to, buddy.
Well, so I've been working in this industry for 30 years, more than that, maybe. I've just been doing it since I was a little kid, but I mean, literally like pre-teenager. And so, but I think more recently, I did the .com thing, learned about what scale was when we were doing tens of users, and it was epic. I think in the more recent thing, which is more relevant to this discussion, I started getting involved with Cassandra in 2011, and as a end user, and let me tell you, if you wanted to be an end user at that time, you had to be writing code and be willing to dig in, because it was like, I think I was using 0.7, 0.8 in production. So, it had a YOLO feel to it, but even then, if you got it right, the thing was invincible, and that's what solved a lot of my problems. I dumped so much Oracle installing a 0.8 cluster to do a lot of the work I needed to do. So, I mean, it was one of those things where I was like, oh, this is pretty sweet. And it was when NoSQL, the alternative databases were starting to pop up because of scale issues. And I just got really into Cassandra. I thought, this is a really cool architecture. I think it's, it's based on the Dynamo paper, has some great stuff in it. I was a fan of the Dynamo paper. Then I just started devoting a lot of time to it. And I did a talk at a conference. And then one of the founders of DataStax, Matt File, he kept bugging me. It's like, hey man, why don't you just do this full time? I'm like, oh no, man.
Yeah.
Yeah, that did. Well, yada yada yada. I listened. Yeah. So I decided, I'm going to spend, some part of my career making this an awesome database and helping others get used to get into it and maybe change some people's fortunes in the way.
Yeah. You and I, you were in like a little bit before me. I think I wrote my first blog post about it in 2012. And I think that's actually when you got a hold of me. You were like, hey man, like let's do, like, you and Christian.
Yeah. Well, you were doing CQL engine and you were like, hey, I'm going to make the Python experience awesome.
Yeah.
And that definitely put you on the radar.
Yeah. It was that, and I'm writing, and I moved off of Mongo, which was like, I hated it. I was like, this did not make sense. This database is not for me. And
I think along the way you just realize, databases are hard, and they could be easier. But it is like it's a continuous effort, because you never just let it sit there unless it's Informix. Informix has not changed at all, but that's the way it was built. It's meant to be like this thing that runs in the corner for 35 years. But we've been keep changing it, and we keep moving the needle. But it's fun to have like involvement. I mean, you and I have been involved in so many interesting discussions, and dropping code and working with end users. I think that has really made it a lot of fun.
Oh yeah, it's remarkable. So when I decided to start Rusty Razor Blade Consulting, which I realize is kind of an insane name. If you have never, like, if you don't know who I am already, it's like, what is this guy? But when I decided to do this, a lot of it was predicated upon like, what am I going to have fun doing? Like, what do I actually love? And I actually really, I'm openly critical about things I don't like. I'll openly praise things I do. Project as a whole is amazing. Like, it is a phenomenal project. It's really interesting. It's changed my life.
Well, the people, the core group of people that you and I have known for way too long. It is like a family in a lot of ways, because we bicker, but we all love each other in the long run. It's just, I think it's probably the most impressive group of people I've ever worked with in my entire career.
Definitely. Yeah. This is it's like, let's take a hard problem, databases, make it harder, distributed databases, and then like even harder, where it's just like, now we've got like a huge range of problems. We've got people always pushing the boundaries, no matter what we think we know about Cassandra or databases in general. People are always like, oh, I want to do this other thing. And it's like it literally is just this like crazy flywheel, where we're just like, okay, cool, like let's build some new stuff, and then someone's like, hey, that's cool, like what if we did this? And the momentum has been amazing. Like it has really been crazy. We've tried a lot of different things as far as running the project, and I think now we're in a great groove. I think some of it, and it's interesting. I will actually tie us into our conversation today with this. Some of it is kind of like, if you think about the business model of DataStax and the way that it's changed so much over the last decade, and now kind of the approach that DataStax is taking today is very different than it's been before. DataStax went from a product company selling DSE as its like main thing, and now Astra is this in like fast growing kind of like crazy thing. You guys are so production focused, because it's really kind of changed. From externally at least, it looks like it's changed the culture of the company completely.
Yeah, it has. And Chet, our CEO, he's it's top down. He's like, this is we want to be the number one operators of Cassandra.
Yeah.
And that's means that we've got to make sure that it's not killing us along the way. Those of you who like ops life, good job, everyone who's got a pager, I mean, we've all been there, right? Pager duty. Oh God, who wants to be on call at 3 a.m. when a database goes sideways?
Oh, that's the best, man. That's the best. When you get woken up, you're like, who needs sleep?
Yeah, no, it's great, man. Let me put my thinking cap on. Because it never breaks at 3 p.m. It's always 3 a.m.
Yeah, that's like I said, it's the best time. It's in UTC though. It's like completely reasonable.
Oh yeah, I forgot. Yeah,
that's
everything's
why.
in UTC.
That's why it thinks you're up.
Yeah.
So for anyone that doesn't know this, doesn't know our history, we worked together for like 3 years or 4 years or something like that.
Yeah, at least that. Yeah, I was another one of those things where I'm like, come on, man, we got candy. Let's go do this. We have. I mean, I because you were out there just already being an evangelist for what Cassandra was, and what I said as I like, you could get paid to do that.
We could do this as a job instead of your free time.
Yeah, exactly. You don't have to just wait for the weekend to do it. You can just do it all the time. But yeah, those were some of the most transformative times in Cassandra land.
It was huge. We went from doing like small meetups to these
massive
500,000 people coming to a conference we're putting on, literally packing. I remember when we did the first one out here in LA, my backyard.
Saturday LA.
Yeah. And we were like, actually, no, the first one was in Denver, I think, or no, Seattle, or something like that.
Yeah.
Seattle. And way more people came than we thought. And and then all of a sudden we're like, okay, we're going to make it a thing. And then we had like 500 or 600 people show up. And we were just like, oh my God, like this is nuts. And I think that's when when we really were vibing with that formula. We were just like, okay, a lot of people want to know about this stuff. Let's bring it to them.
That's that goes to the fact that not everyone's running Cassandra as their primary database, but most likely everyone has at least a little Cassandra in their environment, because there's no other database that does what it does. It's pretty unique. And what's really fascinating, and this is a great talk track from Scott Andreas, who's the engineering manager at Apple. He has this great presentation. If it's online, if just look for Scott Andreas and Cassandra, but he has this great talk track about like why he puts his time and energy into Cassandra, but mainly he lines out some things like this database is the only database that does this, and there's been no one else that's even attempted to try it. So it's a unique moat. It's also super painful because that is a hard problem, and we keep plugging away.
Being on the beginning, like being at the very beginning tip of the innovator's curve is incredibly fun, and also a curse, in that we're just like, we're doing new stuff, like literally inventing new technology that doesn't exist elsewhere. And
I recently I did some back of the napkin calculations, and I was using some various data sources, but I figured out that there are around, I am estimating that there are around 10 to 20 million Cassandra nodes worldwide. And
really? I never even thought. How did you get there?
Oh, it's long. It was a long process.
Derivatives.
Yeah, a lot of math, and I always forget to carry the one. What I did is I looked at, like, we have the extra super whales like the Huawei's, Apples, and then there's some large installations, 1,000 nodes or more, but there's so many of these mid-tier, the 100 node clusters or less, or 500 or less, and then there's an enormous amount of like 5 to 20 or below.
A lot of
because the 5-node cluster is a starter, and those are the ones I think actually that turn out to be someone spun it up in 2013 and forgot about it, and it's still running like a critical part of their business.
I think that's definitely true. I see a lot of smaller clusters, and I think there's a lot of use cases where people just want the replication and the availability, but they don't necessarily have the enormous scale. But they want to run in 2 DCs or 3 DCs or whatever number of data centers. It's kind of like, at this point, it's kind of a no-brainer, like because it's built into the architecture to work multi-DC. It's not something you can just add on later and have it make sense, because the entire paradigm breaks. Like, you start doing cross-DC replication with relational, and it's like, well, unless it was actually designed for it, it's weird. Like, it's super weird.
You denormalize your data sets and you dump ACID transactions because they're probably not needed for what you're doing in that case anyway. And and then at that point you're like, wait a minute, well, I'm using the wrong database.
Exactly. Like, and then you move to Xander anyway.
Well, and it's funny, and this is like, I'll just kind of end with this kind of funny story. We were working with this customer. They needed to do a consulting agreement, and they're like, oh, we only have a few hundred nodes of Cassandra, and I'm like, oh, okay. But they wanted to find out, and we asked them, like, are you sure? And they're like, yeah, well, and so they went to their security team and they started doing internal scans, like, how many do we actually have running here? And it was close to 10,000 nodes. And
how do you not know that?
Exactly. Well, that was the funny thing, is they're like, oh, and it's because it was these application groups that would spin up a 3 or 4 or 5 node cluster on the cloud to run some part of their app that was needed. And
that's crazy. I've never heard of a team like doing that.
Well, it happens, man. I mean, come on, you've worked in application teams. People are like, hey, I'm going to use this thing that isn't on the official list. I'm just going to go do it.
That's how I got started. That was my first cluster. I was like, I'm putting it in production, because actually that was the one that replaced Mongo. I was like, we're using this.
Exactly.
And nobody knows about it. And I'm just off rewriting code and like doing all this stuff. I was like, by the way, we just went from like timing out at the ELB to like 10 millisecond response times.
I've seen so many 6-node clusters where they have 3 in 2 regions, or three per AZ, just to get the uptime. There's 0 downtime in that. There you go. Good job.
So let's dig into Astra. Now we know who you are. Now I know who you are. That's
Did you know me before? Well, now you do.
How did you get here? Let's talk a little bit about Astra, because I'm seeing a lot come, like, at least on like LinkedIn. I'm seeing it in I know the Register's had some articles, like we've talked a little bit about kind of what you're doing over there. It's really interesting. I think that there's some really clever technological choices. I think that the business side of things is changed. I mean, maybe you could kind of talk about
the brief overview. More overviews. Yeah. So those who don't know, Astra is our Cassandra as a service, and in a nutshell, I mean, if you're familiar with Cassandra, this is a Cassandra as a service, but it's meant to be really cloud native and easy to use. So like if you've never used Cassandra before, it's easy, because you just click a button and you get a database. And if you've used, it's actually harder for people who've been using Cassandra for a long time, because we do abstract out a lot of things, but the things that we do abstract are ops. You don't have to do any ops, and we built it in a way that it is serverless, so you can scale to 0 if you want, and made it really easy to pay for. You pay for what you use, so it's all based on consumption. You don't pay for a running cluster. That's that can be.
How does that even work?
How do you do that?
Sounds like madness. How does that even work?
What kind of magic is this? Well, so nice lead in. Good job. Tell
me about that.
Leading question. So it was interesting, because we started doing the Cassandra as a service when we started doing that as a cloud service, it was spin up a cluster, and you had to pick how many nodes you wanted and all that, and you paid for running cluster time. And I mean that's handy, but it doesn't fit the way that a cloud native database should be. The cloud native database should be very transparent and elastic, and the elasticity is a really hard part. You can scale up Cassandra really easily, but scaling down is harder. The other key component is multi-tenancy. For us to provide a service that is a reasonable price for everyone, we had to do multi-tenancy at scale, and another hard problem with Cassandra. So we shifted the paradigm, and this is Jake Luciani, who's a longtime Cassandra committer. He was one of the lead architects on this plan to basically re-architect, or I want to say like do a decomposition architecture of Cassandra in a way that we could run it differently. And it was very tricky, because the two things we can't have is a fork of Cassandra that will never ever work with Cassandra ever again. We can't have that. And we can't turn it into this super specialized database that no one can use or that can operate. Yeah. So like when we hire a new engineer to work on our database stuff, like our internals, it can't be like a completely foreign and new database, or it'll take them 6 months to come up to speed. So those are two really important things. So, and this is just kind of a high level, but what we have now and what was built is built an architecture that can use Cassandra as it is, open source Cassandra. We don't have to fork away from it and do something completely different, but in a way that's reasonable, or it makes it easy for us to do it in a cloud architecture. Okay.
You want to? Is it a secret how you do it, or is it, or do you talk about it?
Yeah, no, I mean, of course, it's not a secret. The one thing that I think will shock everybody is we use Kubernetes for everything. That's a really important piece.
That does shock me. It does shock.
Shocking, but true.
100% of the people you're talking to.
Shocked.
I am.
Yeah. Clutching your pearls. Not Kubernetes.
I have had the pleasure of using Cassandra on Kubernetes in a couple of different environments, and I'm interested to hear how it worked. It worked well for you over there.
Yeah, it's really the two things that I mentioned. We still had to stick to, right? We had to keep with Cassandra, but we had to make it so it didn't kill us. So. And you're right. Kubernetes can be a beast, but it can be an absolute lifesaver when you get to a good peaceful place with this. By the way, wrote a book about this. If you want to check it out, managing cloud native data on Kubernetes in a bookstore near you. Hey,
that's
right. Let's
get an image.
Yeah. So what we did is we broke up the architecture. So in a typical Cassandra node, it's monolithic. So you have a coordinator. Here, I'm going to use visuals here. Coordinator. Yeah. You have which does all the work with the client communication, coordination with other nodes, and then you have your storage layer down here. And the storage layer manages the bits coming in on off the disk, and manages and the coordinator talks to that. And it's all a pipe, right, on a single machine. Breaking that up was important. We had to separate the compute from the storage. Yeah. Because in a cloud native environment, storage scales differently than compute. And if you think about when you scale a Cassandra node, you might do it for one or two reasons. You may need more IO, ops per second. That's a different problem. That's you need to scale compute. It could be that you need to store more data on disk. That means you need to scale for storage. And so we separated those two things. And essentially what it was we took a hammer to Cassandra and just kind of broke it into pieces, and but instead of and broke up the individual parts of Cassandra into microservices. So those scale differently, and that's we've got some techniques that we use to do multi-tenancy, but essentially we can run thousands of Cassandra clusters in a Kubernetes pod and have it scale pretty independently. And we can migrate, if you have an increased workload, we can move tenants in and out of different pods. We built up a really interesting way of managing Cassandra clusters at scale with multi-tenancy. The other thing is that if you're broken into microservices, then whenever you do compute stuff, say for instance, and this is where serverless type technology should work, is say I'm doing 1,000 writes per second for 10 minutes and then I stop. Well, you should only pay for storage at that point. And you shouldn't have to pay for a running cluster, and you won't. But also, if you start really hammering the cluster, then it should scale up and scale up and scale up. And we have different tiers there, but it should ramp up to whatever you need, and you just basically I'll pay for whatever I need. And so that's consumption-based pricing. And
so you've decoupled a whole bunch of the different components to allow them to scale independently of each other.
Yeah, that was not easy, but we have load balancers and things like that normally you wouldn't put into a Cassandra cluster, but by breaking into microservices and putting some wrapper code around it, we made it work, and it works really well. We could spin up a Cassandra cluster in less than a minute.
Kind of like Easy Cast Lab. Oh, self-promotion.
Another shameless plug.
Shameless plug for my own stuff.
That's good. But yeah, I use it all. I mean, I think right now we have tens of thousands of clusters running in our system. Most of them are just like little toys. I have 5 running right now. A lot of them are for people testing and trying out things, but we have some pretty large clusters. Well, and that's the other thing. It's hard to say how big is a cluster. I mean, there's no node count per cluster anymore. That's probably the other thing that's going to be, because we went down this path. It's a cloud service. You don't get the same experience as if you're managing your own cluster. Like Node Tool, don't need that anymore. Yeah.
Well, I would love to see some of that stuff make it into open source from the perspective, because I've always wanted to see Cassandra be more decoupled. Like to me, it's never made sense that you can't independently use parts of the code base in your own code bases. Like I know that there was a comment years ago, like long time ago. It was like Cassandra's not a database toolkit, but I fundamentally believe that it should be, and it sounds like you guys are using it as one in order to kind of take the right pieces out of it and use them in a way that makes more sense resource wise. And I think that's a smart. I think it's a smart approach, like a monolith for this type of thing, where the resources really demonstrably don't scale. Each one of them doesn't scale linearly, especially with workloads.
And I see Frank Moley's in here.
Frank. Let's give Frank a little love here.
Yeah. Frank was a part of that. It was great because Frank was a part of that initial cloud team that had to do a lot of the hard work. And, it was, I mean, there was a lot of late nights. Am I right, Frank? But, it's gotten into like anything else you build from scratch, there's first couple of years a little rough, and it gets better over time. And eventually we'll do something else to make everyone's life miserable in ops. But, I think it's worth mentioning, you mentioned that, I hope we contribute back. This is and I'm very happy about this, this is a philosophy that we hold internally where, everyone that's running a large scale Cassandra probably has a fork of forward features. Like, hey, here's some stuff we're working on, or here's some test stuff that we're doing. Of course we have that, but we always try to keep as close to mainline Cassandra as possible, and we call it converge core. Like we need to make sure everything is converged. We don't have separate that's right, late nights, that's right. Hashtag ops life. But we make sure that we're not diverging away from Cassandra, and also donating those things back to the project. So we always want to go upstream. And it's at a slower pace because, like the Cassandra project has its own pace, which is great. It's kind of got a Debian kind of pace, which is good, and it has to be stable. We get the ability to do some extra weird things in Astra and try things out. Like we've gone directions with customers. Like customers will be like, "Hey, we'll give that a try." We can because we're running Kubernetes. We can just say, "Hey, we're going to spin up something extra over here." That didn't work. All right, quick, delete it and act like
delete it.
Yeah,
that's pretty interesting. And that is one of the areas where I think that because the business model fundamentally changed. I think DSE. The history of DSE was pushing a lot of stuff into open source and then kind of like releasing it like a year or two later in DSE after like a lot of bugs got kind of shaken out by the community. I much prefer the new model where the stuff that's getting contributed back has been put into production. It's been like it's gone through dozens of iterations of bug fixes. SAI and is probably one of the best examples of this. I know that you guys have run SAI for a while, and then so you dealt with the pain points, right? Like you already kind of felt a lot of the ran up against a lot of the limitations, overcame them, dealt with it. So instead of kind of like pushing on the open source community, it's been very much like bringing out something that's going to work a million times better. So I think it's I think it's a good thing. It's a healthy thing for the project. And to me, it makes sense for DataStax as well to be able to do that, because you can offer stuff that you don't necessarily have to like go through the process of getting it committed into Cassandra, going through that whole process. You can move fast in your own architecture and then get it to the community when you know that it's where you want it to be.
It's an important thing, and it's a maturity of the project. And I think this is where open source companies, for lack of a better word, really, if you're lucky enough, you can be in a situation like we are, where the thing that we derive money from, the thing that helps pay engineers, is consumption, and people using a product, and we don't. It doesn't go against Cassandra. It actually enhances it. I think it was you that said this years and years ago. That said Cassandra will get infinitely better as soon as DataStax becomes a user. Yeah, and that happened. Yeah,
it's a huge change in perspective when the code you write is what causes you to wake up in the morning. You think a little bit. You think a little bit harder about it.
Things like guardrails. So we could talk a little bit about some of the things that exist now because of running a cloud service. Guardrails is a perfect example of, we've always said this in the project. We've been saying this at NGCC for 100 years. It's like we need to be able to have operators control the boundaries of what users could do, because it was pretty much a YOLO database. Right? Any user could do anything, and there was no constraints. But it was like role-based security, but then guardrails, like being able to put limits on things, like how many indexes on a table, what kind of queries you could run. All of that stuff, became quickly important when we're running a cloud service, because because we're running SLAs and things like that. You can't just say select star on my database, allow filtering and expect millisecond response time.
Yep. Yeah. Nice. Yeah, man. and then there's also vector search on top of SAI, which I think is, I know that DataStax is now, what did I just see? You guys are just one, like, you're in like one of the top AI companies in the world now. I forgot who just released that list. It's like, whoa.
Oh, yeah. That's Sequoia, I think. Well, there's been a lot of lists, and we got vaulted up there, and thank you, Cassandra, because the Cassandra workloads transaction. This is what I've been saying, and I think this actually makes the most sense, is transactional AI. So we've been doing batch and inference on AI for a long time, and that's where the sparks were. And now that we're moving into this transactional AI, like what else would you use besides Cassandra at that scale?
Yeah, especially if if you're already relying on the replication mechanism, if you want fault tolerance,
Yeah.
it makes
Well,
sense.
so yeah, when the vector search is just a good example of like, hey, what can you do with a database that has that kind of pluggability? And
Mhm.
it was so this is Jonathan Ellis, man. He's still the man.
Yeah.
And if you don't know who Jonathan is, just go look him up. But you know, he go look at Cassandra 1 in the Jira, in the Apache Jira. Jonathan did that one.
Yeah. Yeah,
And
wasn't it like bring the repo over?
oh no, it was delete. He added the ability to delete data.
Oh, I didn't realize that was
Somebody
it didn't even
that's
exist
listening can
before.
go look. I think
Wow.
that's what it's a funny name ticket. It's like delete database or add delete or something. It's really a funny name ticket. Anyway, yeah, Jonathan got, you know, he started going down this path of like, I think this is the right fit. And man, he had a prototype running in a couple of weeks because he just used all the other stuff that was available inside of Cassandra, like SAI and index building and all that stuff, and just hung a different kind of index type off of it. And at the time, he was using HNSW library from Lucene. So that was a nice plugin experience, but it was quickly evident that HNSW built on Lucene is not the right fit for Cassandra workloads. And so he flipped into this thing called JVector, and that's a separate open source project right now. It's kind of moving at its own velocity, but it's being fed back into Cassandra, and will be a part of 5.0. It's in there now, so if you want to go play around with it. But you know, the thing about what JVector is it's fast mover for sure. But what's really cool is all the people is bringing, like new blood is bringing out of their woodwork. Jonathan and I were in a call with a team from Intel that they were researchers working on some stuff around compression and vectors inside of CPUs. And they were like, hey, we want to be involved in this project. And it just because, there we go. Thank you. They wanted to be involved in the project because, you know, it's like, oh, this is in our world. And so, you know, these research team from Intel is going to be contributing to the open source project, you know, and it's just, it's igniting a whole bunch of new interest, which I think is great. But, you know, building vector search into Cassandra is one of many good things, especially with RAG workloads. You know, the retrieval.
And I've talked to some folks who also used it for geospatial search, which is really interesting because it's that makes complete sense. You know.
Yeah, and also, you know, it using hybrid search now. There's specific vector databases out there, but using hybrid search, you know, being able to search for other terms besides just a nearest neighbor. It makes a lot of sense, especially in large scale data. When we get a terabyte of vectors, you're going to want that.
I think the ability. Yeah, you mean the ability to like have multiple indexes get used in order to like provide. You know, you want to do like a geospatial or a vector search on one field and then like a text search on another one.
Yeah, like think about IoT data. That's probably the best example. Is you don't want to like say, give me the nearest neighbor for this random thing, and let's say you have 10 terabytes of IoT data. You want to say what's close within this group or this neighborhood or maybe this device. And so putting a predicate in there and a where clause. So putting in a partition key and then adding an ANN clause can make it so that you don't have to go randomly scan your entire database. First of all, when you're talking about accuracy, that's a big deal because, approximate nearest neighbor, the approximate part, there's like, well, I think this is close. And usually it is. I mean, we try to get into the 90% range, but that's the thing to remember. It's like, that's it's not saying this equals that. You're not going to get a one-to-one match. It's going to do the best it can in the time limit that it has and on the scope of data that it has. The vector space is like that. So getting closer will get your accuracy, really your relevancy score really up there. And there's some really cool things like Colbert, which is this way that it does multi-indexing. So it uses 2 different vectors to narrow down the accuracy. It requires a lot of transactions. Well, again, right up Cassandra's alley.
Yeah.
So yeah.
I have 2 comments. One on JVector. I'm looking at trendshift.io, and JVector looks like it's one of the most popular repos on all of GitHub. I don't even. I'm like, am I reading this right? Like this.
It was the number 1 Java repo on GitHub for a long time.
Yeah. Pretty wild. And then number 2, Frank.
Yeah, Frank's dropping the bombs, man.
I love it. I love it. So scalar and vector sequential search is really important, especially for filtered results. Simultaneous scalar and vector search is really important. Yeah, it makes sense to me. Being able to, and this I think is going to be where some of the advancements kind of potentially with the CEP for the cost-based optimizer will be really nice, because
I'm really I'm excited about that work.
Yeah, it's going to be really interesting to be able to have like truly several indexes that have different like characteristics, and for it to know like the right the right thing to do is going to be really cool. And that's of course going to open up potentially possibilities for big expansion of CQL.
I think so. And, there are some really cool things pending in the CQL world for sure. I mean, and not CQL, but also relevant for what we're talking about is things like TCM, changing the way we manage large clusters and being transactional about those things has a ramification in large scale indexing. It's like being deterministic about how things get indexed and when. If you're talking about trillion rows of data, then moving around, scaling it, all those things. I mean, those are exciting prospects and coming. It's only going to make it better. Yeah. I'm looking forward to that. I mean, it's like Cassandra is like still like every morning, like every new version is like Christmas. I love it. It's like I can't wait to unwrap the present.
It really is crazy. It's like every version there is some parts of it that just blow your mind. Like I don't know if you saw the and this is actually something that DataStax contributed, the try mem tables.
Those are pretty amazing.
Wow, dude. Let me just rant about try mem tables for a minute here, because I ran a write heavy workload, and I was using the on heap mem tables, and I was getting, I think it was only like, I was doing a small test. It was like either 1 node or a 3 node cluster. I was getting 40,000 writes a second. Okay. And I had a easy cast stress lets you specify a maximum latency, and it will throttle the reads and writes so that it falls within your SLO. So you can say like, hey, like, don't exceed 20 milliseconds. What throughput can I achieve?
Right.
And I did that. I think it was like 20 milliseconds, and I was getting 40,000 requests a second. Now there were like GC spikes, and it was kind of like, so then it would slow down. Like I hit a GC spike and then slow down, and kind of the numbers were between 40 and 50. I rolled out try mem tables. The only thing I changed was try mem tables, and it went to 140,000 requests a second while maintaining that same latency. That's insane. Like that is, people don't realize how much room we have still. It's like, if anyone thinks that Cassandra is like complete and done and there's like nothing else for us to do, there's so much, and there's so much exciting things going on like that. Like to be able to have massively more predictable performance, huge reduction in allocations. It's really, really remarkable. And then the try indexes I haven't yet had a chance to work with yet, but I'm hoping
it's the same thing. And those of you out there who are not sure what we're talking about, the really, really basic thing about tries is that they align the bytes so it makes comparisons easy. So, and if you think about the most costly operation when you're looking for something like pouring through data is the comparison operation. It's like, is this? Well, if you can find a way to make that easier, like almost no CPU, which is what it is, that's what this does. And it's remarkable.
Yeah, it's much friendlier to the heap. So even without introducing any GC tuning, like I think I left it basically out of the box. A lot of these tests I don't even bother tuning everything like I normally would if we like cared a lot. So first one was running GC spikes, right? Second one, try mem tables, and it was like I actually had to ask myself, did I do something wrong? So I had to run. I was like, did I get this right? Like, did I do something weird here? Because it was so good that it didn't even make sense. It was
what JDK were you using?
17.
Wait until you try 21.
So I actually have a patch that makes Cassandra 5 work with 21. So I have gone through it, and I ripped out the internal queuing SEP worker and replaced it with a cached thread pool.
Yeah. Now then you're talking about memory alignment as well, and then what's happening with GC, like Shenandoah, it's just really it's impossible to even see where the limit's going to be at this point. We're bare metal at this point. And then the Panama extensions that are in 21.
Yes.
The J vector that runs on 21 uses Panama for all it does SIMD on the processor.
Tell us a little bit about that.
Yeah, it's really interesting because it's like you're cruising along and it's like, Star Wars when they go into hyperdrive, all of a sudden the stars go.
Yep.
Whoa. Did you just toss one instruction on the CPU and you're like, hey, go do the same thing to all this data.
Yep.
Bare metal.
Yeah. It's so the generational ZGC, I think that's Java 21. The Panama stuff, there's so much runway and so much to get excited about.
Taking it back to our topic, this is stuff that we get to try and scale in Astra, and we are.
Yeah.
Because our incentive is to run Cassandra as cheap as possible.
Mm-hmm.
And no density, probably shameless plug for that team, but the universal compaction strategy was that's about saving money,
and it is also awesome. I
contributed.
Yep, I did a whole test on that too, and the thing that I love the most about that is there's a bunch of things I love about it, but the thing that is really exciting is that if you drop in replace it for STCS, it can behave like almost the same, but it will make it much friendlier for full SS table streaming. Yeah. And once you tap into that, you go from like 20 or 30 megs a second of throughput to saturating in NIC. And I looked at the numbers. I was like, these are numbers that are completely insane. I was like, how is this happening? I've actually hoped so. Hey, if DataStax is looking for some stuff to do, I have put up several performance related JIRAs that would improve things quite a bit. So
on. Well,
take a look at those. I'll send you those later.
Yeah, sign up for Rusty Razorblade Consulting. You cloud service, you.
Exactly. If you need some ideas, I've got them.
Well, we've hired you before, and we'll do it again. I can endorse John as fully as I can.
Oh man, I'll have to go through a coding interview. That's what.
A real DataStax. Or we're a customer of Rusty Razorblade.
Yep.
Thank you, iOS.
Yeah, man.
Mac OS. But yeah, I mean, you know, that kind of stuff, like being able to be a little more cutting edge, bleeding edge, and then having, you know, so we have some pretty large tenants in Astra, and we can do things with them to try to like see where these limits are. And then what it does is it helps us learn, you know, like if you saw like E-Kate Arena is talked a lot. She was on the mailing list talking about all the work she was doing with getting JDK 17 upgraded and things like that. You know, those part of that work was trying to get what we were doing in Astra working right, and she, you know, that was all done in the open in the mailing list. And you know, those are the kind of things that, as a large enterprise that's running a crap load of Cassandra inside of your own firewall, you can feel good about. You're like, oh, I know that there's been people out there testing and trying this, and they probably found a lot of stuff. But that doesn't mean you can't file a JIRA if you find a problem. Large enterprise that's running Cassandra.
Let this be a lesson to you, listener.
Yes.
File the JIRA.
File the JIRA. Be friendly. File a JIRA. Give a hoot.
Why not? Tell us what's going on. Yeah, it's great. Cool, man. Well, I like the way that this is working out. This is nice.
Yeah, it is. It's like, it's nice for Cassandra land. Yeah. Yeah. And awesome, man. Well, if you have more, I don't know if you have more questions. I don't know what your time limit is, but
I figured we'd go for about an hour. I think that that's probably the right amount of time. So if you want, we got a couple more minutes. Anything you want to plug? Anything you want to talk about?
Yeah, actually. So let me tell you what I've been working on.
Lay it on me.
Lay it on me. Speaking of Gen AI, so next week I have a webinar, and I'm doing three steps to success for Gen AI for Cassandra teams. And it's just, hey, you've been doing Cassandra for a long time. Time to mount up, man. We're going in, because this is our time again. There's some really interesting transactional problems here. So I'm doing that next week. You can go on DataStax on the events, and you can see my friendly face there. Just click on that. I'd love to see you next week. But what I'm going to be talking about is a contribution that I just landed. Well, it isn't committed. It should be committed today. So this is April 17th. It's my daughter's birthday today. So April 17th. Hopefully it'll be committed today. But I wrote in LangChain, I wrote the Cassandra toolkit for agents. And it's a pretty slick little piece of kit. It essentially allows you to, thank you for posting that.
I'll put it in the description too, man.
I love that.
Gotta let the world know, buddy.
Let's get it out there.
Yeah, man.
To see you.
Yeah.
I'm sure you're going to be there too.
I'll be in. I'll be there.
Heckling.
Yes. Oh, definitely heckling.
Oh, yeah. This guy doesn't know what he's talking about. But yeah, this contribution to LangChain I made. So agents have the ability, or when you're using a large language model, there's this whole thing around using tools. So you can you can make it aware of like, hey, here's a list of tools that you have, like go do a web search, or here's an API call you can make. What I'm doing is I'm giving it a toolkit to interact directly with Cassandra. So go get the schema from the database, select data out of the database, that sort of thing. Instead of having it like dream up CQL, it says, oh, I need this information from this table. And the toolkit will go and grab it and pull it into your Gen AI app. Yeah.
That's on
LangChain?
Okay. Did I
have not. All right, so it's the PR is almost done. I'm waiting for somebody to hit commit.
Yeah.
So by the time I have by next week, it should be there, because I'm going to be talking about it.
So wait a minute. Which one is this? Is this, or did I get the right one or did I get the wrong one? I think did you say it's 3 steps to Gen AI success?
Oh yeah, you did get the wrong one.
Okay. I got the wrong one. All right. We'll put that in the description then. I won't put the other one.
That one.
Whatever. That's an EMEA one.
That's the one. Oh,
okay. So Tuesday, April 23rd, 9 a.m. Pacific.
Yeah.
That's when I gotta be paying attention to this 3 steps for
sign
Gen
up
AI
and it'll be on
success.
replay. So sign up and you get the link. Yeah. So
Okay. All right.
It'll probably be on the YouTubes. The
I love
YouTubes.
it.
Yeah.
It'll be on the interwebs, man, forever.
On the webs forever. Yeah.
And then some other AI is gonna learn what you said, and then just.
What's freaky is I can go into Chat GPT and I can say write a blog post in the voice of Patrick McFadin, and it actually gets it.
Really, I didn't know that you could do that. Okay,
no,
I
plagiarizing
my face might indicate sarcasm or just an overall terribleness when I do this, but I actually was surprised.
Apparently has enough information that it's like, oh, I got this guy.
Yeah,
it's actually a little over the top. I get embarrassed. There you go. There we go. Thank you.
Do it.
Nice
man. StreamYard, baby.
I would love to see you there. But yeah, I mean, I've been spending a lot of time with LangChain in regards to working with Cassandra databases. And I think there's some, I like the idea of the intersection of agents, AI agents, and Cassandra. Because I think the scale that's needed for agents and Cassandra are going to really fit well together. So,
what kind of, are you seeing huge scale on agents right now? Like people, what are some use cases for that? Do you think that we'll see?
Yeah. Well, agents right now are in a limited profile, but mostly around some internal things like chatbots already use agents. So for instance, with LangChain, you can chain together different things, but a simple agent can be like, hey, I want to know about something, this topic. Well, an agent can go access information out of a database, or it can scrape a website or access an API and then bring that data back. The scaling problem I think everyone seems to be having is that the more you involve a large language model, because those are inherently slow. So reducing the amount of dependence on that, using them as sparingly as possible, because they're expensive and they're slow. But they are pretty interesting. But I was working with the Auto GPT project and doing some really interesting things there. Really, like Devin is a good example of GPT Pilot. These are all examples of agents. So one thing that DataStax is doing around agents is Copilot. The GitHub Copilot.
Yeah.
Yeah, there will be an Astra agent. So the Astra agent, actually, it should be out there soon, or if not now. There was an announcement at the GitHub conference in November, but it's an Astra agent. So when you're working with code and it's connected to Astra, it will have a live connection to your Astra database, and then be able to say, when you say, make me a function over here that will get the data on this table, it will access that table and then create the accessors for that. That's the kind of thing that it'll do, but it gives us context for all that. Mm-hmm. That's the Astra agent that's running the Copilot.
Got it. Cool, man.
Yeah.
Fun times. All right. Well, I guess I'll have to be there on Tuesday at 9 a.m.
Yeah, I'll go work on the slides now. Ooh, I better get on that, huh?
Yeah, buddy.
Well,
awesome.
The reason I did it is because I still work with a lot of end users, and I think that there's a lot of fear and uncertainty around Gen AI. Like, I think we need to do this, but what do we do? I think it's simpler than you think, and there's really cool things you can start with your existing data.
Can I use Ollama?
You should use Ollama.
I do. I like Ollama. Ollama's cool.
Yeah.
Desktop app. It works. I have a local LLM. It's great.
Local LLM. Yeah. So what if it makes your CPU hot?
Whatever. It's great.
Yeah, doesn't matter.
Yeah.
I've been using Bedrock a lot, and because they just put up the new Claude Opus, and that's really kind of cool.
I haven't looked at
that's the AWS service.
Oh, that's why. I like to do things the complicated, difficult way. So, like, use a service. No way.
Yeah, no way. Oh yeah, no, cloud services are still not super easy. I mean, especially if you're like spinning up stuff in like GCP or Amazon or Azure, you're like,
Yeah.
it's not super simple. Yeah.
There's definitely a lot of investment. I think there's a lot of investment. Either. No matter what you want to do, you got to invest sometime.
Yeah. Oh, and that's why we decided to do what we do with Astra, is just make it super easy, because a lot of ceremony around cloud things is gonna make you not want to do it.
Yeah.
Yeah.
Yeah. And you got to have an advantage to do it. Like it can't just be run it yourself or run it in the cloud. Like it's got to deliver a little bit more than ideally functionality. Like it could be performance, it could be cost, it could be, but like the features I think are and the ease of use is the no-brainer. It's like lower the friction. And I think it's cool that you've that DataStax has done this from for Cassandra perspective. I mean, Amazon kind of dipped their toe into the water with key spaces, and they took a different approach. Your data is still being stored in Dynamo, so it's more of like a translation layer with support for some of the CQL, but not all. Scylla took the different approach, which was rewrite everything, and build kind of a new engine to make everything async. So they go that route. It's hard to tell if that's like a viable long-term kind of approach, because as we've talked about, Cassandra keeps getting faster. Some of the competitive advantage of Scylla with regard to like node density and number of transactions kind of starts to
evaporate.
Exactly. So once that goes away, then they have fewer features, and there's no way that they're going to implement all of the stuff that we have. Like we're just so far ahead of the Scylla project now, feature wise. So I think the Astra approach makes a lot of sense. I mean, there's a lot of people that want it to be easier, definitely more than need it to be, faster with fewer features.
Well, and we've been talking to the Cassandra crowd, but Astra, it has an alter ego. It's also the first database of choice for people building like JavaScript applications with our data API. So we have a completely different API. You'll never use CQL, and it's a completely different type of user. It's the person who's building an app in Vercel or something, like we just announced. We're now Astra data API is now part of Vercel. And it's inviting a whole new class of user to the Cassandra experience in a way that they want it.
What's Vercel? I don't even know what that is. I literally don't know anything about JavaScript.
It's a low code, no code type. It's for building applications. So it's so if you're building like a React application, well, they use Next.js, but if you're using Next.js, the Vercel is the place to go. But there's a lot of sites that are running on Vercel, and it's front end developers that are looking for just getting and putting data in an efficient way and the way that they want it. And telling someone to if you want to come to the church Cassandra, you got to learn how to pray in CQL.
There was
for that, and that's fine.
There was like the early effort to add JSON into it, but I didn't quite.
Yeah, this is much more. If you use Mongo, this will be really familiar.
Isn't it? I remember there was something about Mongoose being involved. Is there something? Am I remembering that?
No, Mongoose, which is the most popular ORM for JavaScript ORM, which is built for Mongo, now supports Astra using our data API because it's pretty compatible. It's actually compatible. So, and again, it's for a new class of user that probably doesn't have, a DB team. It's the one dude and his dog in his basement building an app.
More of a scrappy approach.
And a lot of those apps take off and are important. Yeah.
Nice. All right, man. I think
You got the full picture, man.
yeah, I think I got all I can handle.
Yeah.
Yeah. All right. Well, so we've been going for a little over an hour. I think we're gonna shut this party down. Anything you wanna say on the way out?
No,
I think I
well,
just
hope
gave
I
you a
see
15
Friday.
minute. I just gave you a 15 minutes plug. So
Yeah, let's just go over more.
talk about some more stuff.
I think everyone at this point is like, can you guys shut up?
Yeah, enough, people. Yeah, man. All right. Well, I'm gonna wind it down. Patrick, thank you for joining me today. One of these does oh, it does. Oh my God, that was amazing! That was awesome.
There's some AI for you right there.
I didn't know it would do that. I was hoping. I was just hoping.
I just think we're probably gonna see this every stream now.
Oh yeah, I'm gonna do it.
I
I'm
mean,
gonna
there's
start
this
things
one,
off.
which
Can I get what? I don't know what.
Yeah, it doesn't.
No,
Yeah.
it's unreliable.
Yeah,
God, okay.
AI. It's a fad.
Weak. Awesome, man. Well, thanks again for joining me.
You're welcome.
We'll chat again real soon.
Let's do it. All right.
All right.
Bye.
See ya.